Okay, let's go ahead and do some notes on water. So let's go ahead and start at the top with water on our Earth. If we look at all the water on our Earth, it is divided into three different parts. First, we've got our salt water. Salt water is 97% of all the water that we have on our planet. This is what we discovered in our pasta lab, the water everywhere. Now, unfortunately, this water is just not usable for humans. As an essential resource, this one is not going to do it for us. We cannot survive on salt water. We also have frozen water, which we talked about is being fresh, and so that's good for us. That's about 2% of all of the water that's on the planet. So it is fresh, but it's not accessible. It's not accessible because it would take too much energy to go ahead and get that out in usable form. But there's lots of it. Okay, and then the last is our fresh available water. This fresh available water is 1% of all the water that we have, and we have water in things like our rivers and our lakes, our streams, and this is what makes up also our groundwater. This is where we get our aquifers, like we did the other day in the lab. All right, when we're talking about the circulation of Earth's water supply, we need to go ahead and talk about the water cycle. So during the water cycle, water changes phases. Some green, you're struggling. So water changes phases. And by phases, I mean it can turn to solid, liquid, and gas. All right, so when we're talking about the water cycle, there's one thing that drives the water cycle, and that is the sun. So the sun drives the water cycle. It's that energy that starts everything. Okay, so let's go ahead and move through the water cycle in our beautiful little picture right here. The first thing that we're going to do is we're going to go ahead and have evaporation happening. So we've got evaporation over here. All of that water is leaving the ocean, and in evaporation, we have liquid to gas. This is how we get the water out of the ocean and into the atmosphere. And during this process, it doesn't last very long in the atmosphere in this stage. It'll only stay in the atmosphere for about 9 days. Once it rises up, because it gets colder, the higher up in altitude we go, we have a process called condensation. So this is when we go from the gas and it goes back to the liquid form. When you see a cloud, that's liquid water. Okay, these are clouds. Let me make another pretty cloud. Fabulous. All right, so then we've got another stage to bring it down, no more than about 9 days later, and this is our precipitation. All right, so precipitation, I'm going to go ahead and make some rain coming off, the clouds hitting onto our land. And when this happens, we can get hitting the land and coming into the water, and this is called runoff because the water is running off the land. So when water hits the land and runs off, it runs off into lakes and streams and rivers. And this is where we can have pollutants. We're going to talk about that in a little bit. But not all of it can run off. Some of it can go into the ground. And we call this process infiltration. All right, that's the process of infiltration. Fabulous. Now, when we are talking about where it's going into the ground, this is our groundwater. Our groundwater is what makes up our aquifer. Or it's part of our aquifer, I guess. Aquifer. This is our aquifer down here. It's lovely. Now, in our aquifer, we've got two things. One of them is this area where it's totally full, and this is called the zone of saturation. A zone is just an area, and it is saturated with water. Totally saturated with water. We can also have an unsaturated portion, and so this would be our unsaturated zone that is not saturated with water. It's underground, so this is unsaturated because there's no water in it. Now, where the saturated and the unsaturated come together, we call that, this area right here is our water table. It's the depth in which the water reaches, right? Above the water table, it's the unsaturated zone. There's no water. Below, it's saturated. That doesn't mean that there's not water running through the unsaturated, but it doesn't fill up. Just the filled up part is the saturated zone. Okay, fabulous. Let's go ahead and talk about runoff. So runoff is when we have rainwater and it's not absorbed by the ground. It can't be or just isn't because the ground's already saturated or it's just coming down too fast, but it can't be absorbed by the ground. Okay, and so the excess water flows across the surface. And anything that comes with it, right, pollutants, anything like that, goes with it and then goes right into our lakes and rivers and streams. I guess I can get rid of that other S. All right, flows across the surface. This is where we can get what's called non-point source pollutants. So I'm going to go ahead and put a little bit something down here. This is where we can have non-point. You're going to read about this in just a minute. Non-point source pollution. We can carry chemicals, fertilizer, sewage, all the things we talked about in our capture question yesterday. So carry chemicals from place to place. All right, infiltration is when we have rainwater flows into the ground. It flows into the ground through the pore spaces. We looked at pore spaces in our gravel, in our aquifer, and also our sand. Okay, smaller material like sand has smaller pore spaces. And so it goes through those pore spaces, and those pore spaces we would call like air pockets in the soil. Even though they're tiny, they're still there. All right, great. Let's go ahead and look at groundwater. And we can see over here, if we want to go ahead and label this, this is called runoff. And then this would be your infiltration. All right, groundwater, water absorbed by the ground. It's absorbed into the ground. Water will infiltrate, meaning move through the ground until, oops, it reaches the zone of saturation. Okay, this zone of saturation is when the soil is filled with water. It's like a sponge that just can't take any more. Okay, so when we're saying that the soil is filled, we mean that all the air spaces in between the particles, those pore spaces, are filled. Filled up, no more. That's the water table. Let's talk about that. Here's a great picture of the water table. Okay, so when we're talking about the water table, it's like an imaginary line, but I mean, it's not imaginary, it's there. It's a line which separates the saturated zone from the unsaturated zone. So it's a line in the ground or underground. That separates the saturated zone, which is below, from the unsaturated zone. And that's above the water table. All right, so the height of the water table can change in the seasons. It's not static, it's not stable. If it is a dry season, then it will be lower. If it's a rainy season, then it will raise up. Excuse me. Something that you need to really understand is that when we are talking about changes in the water table and we're dealing with our water wells, I don't care if it is a rainy season or a dry season, all wells must go down below the water table. Otherwise, you're not going to pull up anything, right? You're just going to have like dry. So they must go down below the water table if you're going to have a well. Otherwise, you're not going to draw anything up. Think about your little straw that you created in your aquifer. If you had the straw going down, if I have this, and you had the little straw, this was your aquifer, your rocks, and then you had your water going like this. This was all water, but you couldn't see it. If you had your well go in over here, I guess, if you had to go in here and just go down to that depth, no matter what you did, right, you're not going to go ahead and get any water to draw up. No water is going to come up because the water is not reaching that particular point. Your water is just down below. All right. Down below where your well can't reach it. So let's go ahead and see what could possibly threaten our wells or threaten our aquifers. The number one threat is, of course, going to be overuse. If we overuse the water and don't manage our resource, we're going to lose it. We're going to dry it out. So we could potentially run out of fresh water. So this is when the aquifers will dry. And when the aquifer dries up, if we remember that little 5-minute video that we watched, eventually it will recharge, right? But it could take too long to get to normal levels to a point where we're not going to be able to use it, right? It's going to be dried up for us in our human history, you know, generational, and you won't be able to use that. And what will happen is people will have to migrate. You have to go where your resources are because fresh water is an essential resource. And so when we're talking about aquifers drying up, it means that the use exceeds recharge. Recharge from the water cycle. It eventually will recharge, but not in our lifetime. And so we need to move. The second threat is, of course, pollution. And we're going to start looking at that more. We're going to start testing some water on Monday. So pollution or some sort of contamination. All right, so we looked at contamination in our aquifer that we created, and then we also looked at that map and with all of the wells in Iowa. So you can have chemical runoff. Doesn't just have to be a flood that we've had recently in Nebraska or Iowa due to lots of rains. It can be just any kind of a rain. Any kind of a rain can wash off through a gas station or a driveway. Anything that you have is going to run off and go into the water system. We could have acid rain that we've talked about in the past, right? That's pollution. It goes up into the atmosphere and then it comes down with the rain. It can be fertilizer. From watering, or rather taking care of our lawns or growing our crops if we don't manage it correctly. And then, of course, it can be septic problems, septic or sewage. So these are all the things that we need to think about. We have to be careful because when we talk about water, you know, water is what we say an essential, we call it you can be a renewable or non-renewable, but when we're talking about fresh water, you know, our fresh water we have to take care of. It's an essential resource. And you can look at it any way you want, but I like to look at it as a, you know, non-renewable resource, because if we pollute it and get rid of it, it's not going to be able to come back in our lifetime, right? When we're dealing with drying up aquifers. So it's an essential resource that could be, and I would like to think about it in this class as being non-renewable. We have to take care of it because we need it for life. All right, that's it.